Well, welcome back, and welcome to Unit 2. In chemistry, we study how the God of the Bible made atoms combine and separate and rearrange. But before we jump into the meat of Unit 2, I thought it would be helpful if I took you on a tour of how we have come to our current understanding of atoms and the model of the atom. So our tour of the structure of the atom and how we've come to understand the atom as we do these days begins a long time ago, back in ancient Greece, with this old dead Greek guy named Democritus, and actually his his mentor Leucippus. And I mentioned them in the previous unit, so that's not the first time you've heard of these guys. But anyway, this is around 400 BC, and Democritus is considered the first person to actually propose that everything is made of these little tiny indivisible particles called atoms. All right. So fast forward like 2,000 years, and we get to this guy John Dalton. Okay, he is the one who made the first complete attempt to describe all matter in terms of atoms and their properties. Okay, he's the one that pushed the idea that all atoms of a given element are identical in their size and their mass and their properties. And what we're going to see in these chemical reactions, atoms are combined, separated, and rearranged. Okay, and so that was kind of the next step in our journey to understanding the atom. Okay, fast forward about 100 years, around 1904, we got J.J. Thomson, through a series of tests, discovered the electron, that little tiny particle that has a negative charge. And since he didn't have any other understanding that there were negative charges and that there were positive charges, he kind of came up with this idea that's called the plum pudding model of the atom. They think oatmeal raisin cookies, right? Had this oatmeal cookie with that had both positive and negative charges kind of floating around in it. Thought I'd share this quote that I found from J.J. Thomson. He says, "As we conquer peak after peak, we see in front of us regions full of interest and beauty. But we do not see our goal. We do not see the horizon. In the distance tower still higher peaks, which will yield to those who ascend them still wider prospects. And deep in the feeling, the truth of which is emphasized by every advance in science, that great are the works of the Lord." All right, so let me introduce you to Robert Millikan, kind of the next figure that had an impact on our understanding of the atom. So J.J. Thomson discovered the electron. Well, Robert Millikan, through a series of experiments known as his oil drop experiments, figured out how much electrical charge is on a single electron. And I like what Mr. Millikan had to say here. He says, "This much I can say with definiteness, namely, that there is no scientific basis for the denial of religion. Nor is there in my judgment any excuse for a conflict between science and religion. For their fields are entirely different. Men who know very little of science and men who know very little of religion do indeed get to quarreling. And the onlookers imagine that there is a conflict between science and religion, whereas the conflict is only between two different species of ignorance." Okay. Let me introduce you to Mr. Ernest Rutherford, kind of the next next step on our journey here. He was doing some really neat experiments, and he was firing particles at atoms. And his experiments involved using gold foil, so you might hear his name associated with gold foil experiments. But his experiments, he discovered that there was this nucleus to the atom where all the positive charge sat. Okay, so J.J. Thomson figured out we got electrons. He knew there were positive charges, but Mr. Rutherford figured out that all the positive charges, the protons, were in the middle, which meant that the electrons were now in orbit around that nucleus. Enter Niels Bohr. Niels Bohr discovered almost by accident that those electrons that the orbits are in are at distinct energy levels. Okay? Quanta is what they're called. They're distinct quantities of energy. And so you're going to come across a thing called the Bohr model of the atom. And it shows, again, the nucleus with all the protons and the positive charge in the middle, and then the electrons in distinct energy level orbits around that nucleus. And I have a, I remember when I came across this, it just kind of blew me away. This is considered one of the smartest guys to ever live. He says, everything we call real is made up of things that cannot be regarded as real. Okay? Which reminds me of this verse from the Bible, 2 Corinthians 4:18. It says, while we look not at the things which are seen, but at the things which are not seen. For the things which are seen are temporal or temporary, but the things which are not seen are eternal. Okay, last step on our tour of the atomic model, the structure of the atom, is with Mr. Erwin Schrödinger. Okay? He figured out that yes, these electrons are in these orbits, but we never really know exactly where they are. They're kind of in these clouds. Okay? And so that's our current understanding of the structure of the atom. Now, atoms are really, really tiny. And I thought I'd share this illustration I use with my own students to help get a feel for the relative sizes and distances involved with atoms. So if you take the element hydrogen, and it has one proton in its nucleus, if you make that proton the size of a basketball, then its electron would be about the size of a golf ball, and it would be about 5 miles away. Oh, one last thing. Don't trust atoms. They make up everything.